To form a new star, the first thing comes to mind is the nebula. So what's a nebula? Nebula is simply a huge mass of cloud that contains hydrogen. So due to extreme pressure and gravitational force, these clouds contract together and form a dance at the center which looks like a spherical and light at the ends. The center of the ball occupies 99% of the mass of the cloud. So at present this star is called the protostar, and this is the first stage of a star. Next, second stage is called the steady state. In this state, two opposite forces are created due to the high contraction of the mass of ball. As the density of the center increases, we know that more and more of light and radiation is created. So, thus a new star is born. Now there are two opposite forces which are acting upon each other. And that's first force is called as the electromagnetic radiation. Second force, gravitational force. Gravitational pulls and balances it while the radiation press acting outwards. So it creates a balancing force between two stars. So now the star is either expanding nor contracting. Hence it is called a steady stage. Coming to the third stage, it's called the red giant. In this stage, as a radiation pressure increases behind the opposing gravitational force, the star begins to swell consequently. Consequently, the surface area will be more as a result of this radiation loss, and hence the temperature of star decreases. And the light emits at a very low frequency radiation. At this stage, the star swells very huge, hence it's called as the red giant. As the star envelope expands, the core contracts, and when the temperature reaches 10 to the power of 8 Kelvin, the helium is converted to carbon in the core. So, when all the helium gets converted to carbon, the core cannot contract further. The only force that exists is the output full of the radiation. Due to this, the outer envelope of the red giant gets detached and thrown into space into a huge form of clouds. This huge form of clouds are called as the planetary nebula. Later, Indian-born American scientist called Dr. Subramaniam Chandrasekhar stated a theory called as the Chandrasekhar's limit. It stated that if the core of the red giant is 1.4 times that of a sun, then that star will end up being a white dwarf. Later, Subramaniam Chandrasekhar was awarded as the Nobel Prize in 1983 for his physics works with W.A. Foley. So, after the star has lost its planetary nebula, if the core of the star is 5 times the mass of the sun, then that star goes an explosion called as the supernova explosion. What is a supernova explosion? So we know that the helium is now converted to carbon, and as the star is much more bigger, these carbon particles combine and fuse together to form a carbon core. Now the carbon core nucleus in the core fuse and liberate energy while synthesizing heavier elements like oxygen, magnesium and silicon. This fusion cycle repeats until the iron L is formed. At this stage, due to concentrated TNF pressure, the star explodes. This is called as a supernova explosion. So after the supernova explosion, the remaining part is called as the remnant. Now this remnant consists of tightly packed neutrons. Hence, this is called as a neutron star. And a fast spinning neutron star emits radiation in pulses. Hence, these are called as pulsars. Quasars were first thought to be as faint stars in a galaxy. In 1960, astronomers found that they emit radio waves. Radio waves are observed that they are coming from the galaxies, but no star had been observed to emit radio waves. These objects are called as the quasi-stellar evolutions. These objects have been shortened as the quasars. If the remnant of the star is 30 times the mass of the sun, then huge amount of matter is compressed into a very small region and gravitational force is created. It contracts to such an extent that this is the formation of a black hole. Black hole consists of a very high and extreme gravitational force. The gravitation is so powerful that even a light cannot escape. So how do we identify black hole? If there is a presence of a black hole in a space, the nearby star starts revolving around that. So that's how we identify. If we look up into the space late at night, we can see different colors of stars. This is because due to the temperature of stars. It varies from 2000 to 50,000 Kelvin. The first one is a 2000 Kelvin to 3000 Kelvin. And this impacts the red color. The best example is the Betelgeuse, which you can spot in the Orion. Next is a 3500 to 5000 Kelvin, which impacts orange color, and the best example for this is the Arcturus. Next is the 5000 to 6000 Kelvin and picks yellow color. Example is our own sun. Next 6000 to 10,000 Kelvin, which impacts white color. Example is the Sirius. The last one 10,000 to 50,000 Kelvin, which gives a blue. The best example is the Rigel, which you can spot in the Orion constellations.